What is an asset? It is something with economic value and can provide future advantage, and it has a present and future value. What is asset management? It is the process of managing these assets, and it's very important, such as enabling a firm to account for all of its assets, old or new. We chose a physical asset by DNVGL, which is a wind turbine generator, specifically the V136.42MW. From the studies that we referenced, there are at least 72 expected wind turbine generators to be decommissioned. There are many factors on why asset decommissioning is important. We have a machine-specific asset, so it's important to reduce mechanical failure due to old systems. In this case, the wind turbine generators are said to be 30 years old, owned by the DNVGL before it is decommissioned.
So in this decommissioning, we have three main processes involved, which is disassembly and abandonment, removal from sites, and salvage and disposal. In all of these three processes, we have 6 different components, which is turbine, corrosion system, transformer, transmission line, site access road, and meteorological mask. For the first process, which is disassembly and abandonment, all components from the wind turbine generator will be dismantled section by section, and any fuels will be drained, stored, and disposed appropriately before removal session begin. The main cranes and the base crane will be required to be on site during the assembly session to assist with loading transportation. All cables that will be below the grade clearance of 3 feet will be abandoned, and the side road and the crane pads will be remediated with native grasses. Second process is removal from sites. The removal of components will be transported to the appropriate scrapyard, aggregate rework facility, or landfill. General waste transportation distance expected to be 80 miles in radius to disposal facility, meanwhile around 450 miles to rework facility for any valuable or complex component. Trucks will be used for transportation medium from site to any disposal, salvage, or rework facility. And lastly, local dump truck assumed to have 10 cubic yard load capacity and from local load slips only. Lastly is salvage and disposal. Most of the wind turbine generator components consist of aluminium, steel, and copper. Electrical components such as cable and wire consist of copper, which is very valuable among the others. Most of it can be found in the transmission line, corrosion system, and transformer. However, those disposal things such as rubber from the foundation demolition, roads, and others do not yield any profits. Components made by GRP such as nacelle, housing, and blades will be disposed of. And here is the salvage and disposal cost assumptions.
There are a lot of laws when decommissioning a wind turbine, and the material-specific ones are listed as such. Firstly, for concrete, there are no specific laws to follow, but the main reference is the EU Waste Framework Directive, which is also the same for metals. However, it is more specific for Article 10. Next, for composites and electric cables, there are no general regulations to adhere to but are nation-specific. As for rare earth materials, it is stated by the EU Waste Framework that it is safe and just need to be taken off-site. After that, there's oil, which the main reference is also the EU Waste Framework Directive, but it also has been transposed in Law 22/2011 on waste and contaminated land specifically. And lastly, for site restoration, it is very important that the site that they used, if it's not in utilization anymore, it should be restored back to its original state.
Assumption made is all calculation and costs involved in this report will be given for one wind turbine and in US dollar currency, which includes disassembly, removal, salvage value of a wind turbine generator. The net decommissioning cost is obtained by subtracting the total salvage value from the total project cost. For turbine decommissioning costs, we include disassembly, removal, and disposal, which come out to the total of $157,300. For scenario 1, which is no resale, we get a total salvage value of $163,000, which come up with a net decommissioning cost of $5,700, which is still a positive return. For scenario 2, with partial resale, we get a total salvage value of $227,250 with a net decommissioning cost of $69,900. 6. Risk management during asset decommissioning. Risk is an uncertainty of an outcome differing to the expected outcome, whereas risk management is a framework for actions to be taken to manage risk. Here are the list of risks that may be encountered during wind turbine decommissioning process. First of all, process may be undertaken by unexperienced party. The decommissioning team is lacking of information. The presence of highly hazardous condition and materials. And finally, the potential to create new risk and hazard. How do we overcome these risks that may be encountered? We need to manage our uncertainties. We need to improve our decision making, and finally, we need to create a workflow to help the worker prioritize their work. And now, to conclude everything, we can see that the decommissioning process of a wind turbine generator is not as simple as dismantling and removing the said asset from the worksite. There are many factors needs to be adhered in the most respectful way possible in the whole process of a wind turbine decommissioning. Thank you.